Hi friends, this is the video channel with the engineer, the creator of Deign, the design with respect to the beam element with the openings, the concrete beams with the openings and analyze and designs. So today I have to have the topic about the concrete beams with the openings and their analysis and the design. So today is the beams criteria. So we can go that many sleeves and small openings and many depths which are passing through of it and which make bigger cracks in the beams and it will make the failure of the design. So today I am going to discuss a few about the concrete beams with the openings and the analysis and their design. So let's go into the channel. So the more details kindly check in the upcoming videos in the YouTube channel, the engineer, the creator of DNA. The concrete beams with the openings and analysis designs we are going to see about it. In the construction mode of modern buildings, the many pipes that are necessary to accommodate essential service like water supply, sewage, air conditioning, electricity, and telephone and computer networks. Today, is the modern world, we have the many pipelines with every electricities, which are air conditioners, and many sewage pipelines. So we have it's impossible to pass everything through in a slab. We have to pass through in a beam. So we have to consider these things also in a beam to develop to make a structure safe. So next we are going to see about the classification of openings. So classification of openings, you can see that there is a circular, rectangular, diamond, triangle, trapezoid, and irregular. So these are the openings which will be coming under to the uh, beams, okay, and in on the beams and into the beams, okay. And the circular and the rectangular are the two type of openings which will be more common in the beams, because it is easy to pass into the beam. It is easy to pass into the duct pipes and circular some sleeves and to the some pipelines, and also with respect to the some wires which can be passed easily into the area beam. Then will be followed by the we can see that what are the design considerations which can we have to look on it. So that is I am going to say about some few about. And due to the opening in the beams, the what is the concept? Before that we can say what is the concept behind the failure of a structure. So when due to the opening in the beam, the under working loads to make the small cracking deflection and leads to the develop the failure of the element in the structure. So when we open in the beam, openings in the beams, it will make the small cracking. Initially, they may make a small cracking, and followed by they make the deflection. Then they make the development of failure of the element. And second point is span by depth ratio is not adapted for the beam with the opening elements. So span by depth ratio we are checking with for the from the as per the IS code we are checking over it, right? But for the beam with the opening we should not check over that. It will not pass also, because if you add the beam in the if you add the opening in the beam, it will make it will reduce the some moment of inertia. That means the reduce the cross section area. So so that the span by depth ratio is not adapted for the beam with the opening elements. We can come to the pre-stressed beams. It is necessary to evaluate the effort of pre-stress on the cracking around the opening to fulfill the crack control requirements both at the transverse stress and the full service load. So what is going to say about these things, right? And when if you know that pre-stressed beams, in that effort of pre-stress we have to check on it. What is the effort of pre-stress, and with respect to the stress, normal stresses, and also the shear stresses, to what is the happening how to control the crack crack which will be developed at the transfer stage and also the full service load. These are the things we have to check over that. And then adequate reinforcement to be provided around the opening to make the structure effective in service routine. This is how we can make, right? It is adequate reinforcement. What is the main requirement that I mentioned, right? So adequate reinforcement, what is the stress, what is the capacity, what is the stress strains, what is the happening in that area around the opening, we have to check at least in a randomly to provide the required reinforcement over that area to make the structures effective in a serviceability. These are the design consideration we should follow in the beam with the openings. Then we can see about the beams stress strain behavior for a beam without a small openings. So normal beam, I am saying about this beam without opening, how the behavior I am just want to say compare with the beam with opening. So this is the cross section. You can check your cross section will be there. Strain will be there. Stress will be the equivalent stress diagram. You know about this stress strain diagram, how it come, how will be analyzed. You may know of it. And this is, you can check here the cross section of the areas will be total cross section with the concrete, right? So the moment will be in the anti-clockwise direction. Don't compare with this stress strain diagram. Will be the don't compare with the IS code, because IS code is different. It's a AC code is different. Okay, so in AC code, it came the stress diagrams came out within the form of a cylinder elements. And another thing we have to discuss about with the uh, beams with the openings. Beam restraint behaviors for the beam with the small openings. We have to check over that beam with the small openings and beam with the opening under the pure bending. So these are the beams with the circular and the rectangular holes. Okay. So what is the cross section is changed is this cross section which is the some this rebars, and he can see that there is a void in the cross section. So you can see the void in the cross section, but remaining strain, stress, equaling stress block, everything will be same. So only the cross section in the area is will be different. So this changes will make changes to the everything in the behavior of a stress, strain, stress and equivalent stress block of a element. So this is the basic stress strain behavior. We have to understand what is happening in the beam, normal beams with the beam with small openings. So now I can show something about the shear, how the shear failure of a beam without the shear reinforcement in without the shear reinforcement will be happen in the beam in the opening beams. So this element I can say that this the point load will be there and this the support will be there. So if the here the tension will be developed, here the tension will be developed. It is a normal behavior. So now the cracks will be developed and the shear will be developed like this. This is the normal behavior of a beam with the point load or a weight load under the tension area. If you place circular opening or rectangular opening here, so the cracks develop compared to the normal behavior, it will be more. So you can see the three type of cracks developed, and although this alignment will be the curve alignment will be like this. If you add third term is if you add the circular opening apart from this zone to here, and also this opening to here, if it line passes through the curvature of the shear, it will make a disaster to the beam. If you come to the fourth one, if you make the curve the circular openings away from some area from the beam and away from some area from the left side, the shear will not happen like this. It will happen like this. So the cracks will be like this and crack will be like this. So it will join to the wherever the opening, and up to that area we need to provide the shear reinforcements. This is the basic concept we have to provide. If you provide like this will get fail. So shear reinforcement coming we need required. So if you provide more closed spaces here and if you reduce some closes here, so it will make the big cracks over here. So it will automatically make the shear failure of a structure. These are the behavior which will be seen over here, and then we can check out the types of cracking and the crack controls which we have to see in precessed concrete beams. Now we can come to the precessed concrete beam. What is the crack will happening when you go for a precessed tendons which be aligned in the beam? So what is the cracks will be different. It's not like same as behavior as a normal beam or a normal with the RCC. So when you provide the pre-stress force in a beam, so the pre-stress force also it will make gives some effect of cracks, right? So we have to check that crack behavior with the respect to the opening cracks, how it be behave. So we can check over here. So this cracks behavior will be different. I am saying means you can see here that this is the typing of cracking around that. So if you see the normal cracking, if you came like this, like this, like this, like this, like this, like this, but this crack is different. You can see that the crack like this and like this and like this, like this. So they if you have some rotation for this, how that crack will be then cracking at the mid depth of the opening. First crack will happen in the mid depth of the opening in horizontal, because why? The stresses, we are applying the force in the right, in the dash direction, so this stresses will be more high. Then will be the at the service stage B, the cracking at the opening corners. Then the crack will be opening at the this corners, as per the normal. This corners will have cracking will be happen. There will be shear cracking in the chords. Shear cracking in the chords in this, we can say that if you're opening like this, you can say this is the top chord, this is the bottom chord. So this is the chord they have mentioned, we can say the top chord and bottom chord. So this crack will be like this. And another then will be the flexural cracking in the chords. Okay, and flexure cracking will be this in the mean of a bending, so it will be happen like this, here and here. Okay, the cracking of tension chords, it's the most dangerous is cracking of tension chords. These are the different crack which develop when we provide a opening in the pre-stressed beams. So these are the cracks which we developed in the pre-stressed beam. And next slides we can see how the reinforcement provider to accommodate these stresses. So if you can see that some model failure of a beam by the structures, and it was checked by the Mansour et al 1983. Okay, so if you can check this diagram. Okay, this diagram, so B1, B3, B9, you can see that very small opening, the cracks will be like this in the vertical, in the at of 45 degree, the cracks will be developed. So these also the flexural cracks, these are the flexural cracks. If you compare to the B3, so the flush, this axis of the 45-degree cracks will be very less, but this top chord, bottom chord cracks are very high. This will make to fail. Okay, if you compare, if you make a this much opening, practically this much opening is not required, but for the something for elevation purpose, some people they will make like this. So to support only the dead load, even though if you make like this, we have to check the cracks, how the behavior will come. So we have to think over it. So you can see that the cracks will be developed from the top end to the bottom end, and these type of cracks would be happen in the in the alignment of 45 degrees its axis. Okay, so if we compare to this element, so here the top chord and bottom chord will be somewhat less, but we have to provide that much reinforcement to accommodate everything in that manner. And also if we compare here larger rectangle with the underpinning torsion, in the form of a pure torsion, you can see that the major failure which happened not here and not here, it happened here and here. It's the first failure will achieve here, because if you make a torsion like this, we will make the two opposite moments which happen the same, it will make this cracks failure will happen at here, and after that here it will not failure up to here more compared to the these failures. Then we can at the final some design considerations in the pre-stress, we can say that some so design detailing for ultimate strength. You can see the several investigations by Abdullah and Kennedy in 1995. He give us something statements about the detailings. If you come to the main things in the flanged beams, gap of 50 mm may be maintained between the top of the opening and the bottom of the flange for the better transfer of stress from the flange to the web. They need a 50 mm gap should be maintained between the web, between the opening and the bottom of the flange for the better transfer of stresses. The corner of the opening should probably be rounded off or cambered. Okay. For the beams with more than one opening, the distance between two openings should be at least twice the length of the tensile yield. So another thing we have to check, a main point is the stand should coincide placed with the centroid of the bottom chord to contract the localized tensile stresses due to the bending. I said already between the before that the bottom chord. So in that bottom chord, the tendon should pass over it. We should not provide only the rod to make or the behavior. If necessarily, the precise stand may also be added in the compression chord to counter the localized tensile stresses considerations. That means what he's saying means we can provide the top chord and bottom chord. He's saying that pre-stress can also provide the top chord not to take the compression areas, because that will not act as a compression, it will act also a tensile stresses. As the design conditions will be we have to talk about the pre-stress beams with the opening beam openings. Then now we can see the rebar detailings. The final arrangement of the reinforcement in the opening region of a beam. So the rebar will be provided like this: horizontal bar and horizontal bar we are going over it, and that this original two rebars will be passing over that, and these diagonal rebars, these diagonal rebars should pass over that. It will be minimum 216 to 216 is required, and horizontally vertical, because these vertical bars will be provided at a distance of 40 mm distance they provided of it. So you can see this section, so 300 mm. So total section, if you, this is cross section, it's, don't compare with this one, it's a void. Okay, this is a void. And if you see in this area, you have to make this alignment as some beam alignment and make a T12 T12, and here also T12 T12, and here you can make the bottom somewhat higher, 2T20, so in order to take over all the tensile stresses available here. And then will be followed by the here the reinforced details for the beam for the openings. These are the typical, it's a different type of reinforcement because with the less stresses. So in order to provide like this in horizontal, so you can provide like this in order to make a somewhat safety to the structure, for safety to the structure. But eventually provide like this, it will be the most safety to the structure in order to avoid all the cracking phenomena. Now we can check here about the beams with the openings with in the form of rectangular. So you can see this. This is all the rebars we have to provide of it, and these are the beer. You can see the section AA, section BB, 200 by 400, and here will be the, you can see that how the reinforcement provided 2T12, T12, 2T12, 2T12. So these are the reinforcement we have to provide in the form of axis to take over all the cracking at the stresses. Okay, then this is the phenomena should be provided for the rectangular. They are the more before that I showed something about the three cases. This will be the minimum reinforcement should be provided to in order to save the structure, and this is the first phenomena should be used to safeguard on all the aspect shear, bending, torsion. Okay, then for the rectangular you can use like this. So this crank bar like this, and then upon the 45 degrees Celsius this crank bar like this, and you can make this horizontal two bars and make the top two horizontal bars. This bars in the form of a shear links we can place over that. If you make the shear links like this, here also this two bar connecting the two bars make a shear links also, it will be better for the serviceability of a structure. Then we can, in the next video I will show the problematic analyzing of beam with opening and their rebar arrangements also, how the moment capacity, shear, where to be taken, and what is the arrangements in the rebar. So how the arrangements came, we see some rebars, right? So how it come, how we have to calculate, so everything I can show in the next video. Please check my video and the next page here, and the thank you friends. Thank you friends, and subscribe for the more videos and enjoy the creator of Deign, and share this video helpful to your friends and the students and the designers, and stay home and stay safe. Thank you.